Hey guys, good morning. I'm so excited. I know you're probably not, but my recording device had crashed my computer. I didn't think I was going to be able to make any videos for tomorrow for y'all today. So anyway, let's get started. Today is going to be not so bad of a day on your work. Again, this is one of the reasons I chose this chapter for y'all. I've got very few notes, and then I'm going to set you free. So let's get started. We are in chapter 16. We're doing lesson 146. It's equivalent ratios. And page 367 to 368. Okay? All right, so I'm going to just go ahead and give you a couple definitions, and we're going to get started. Okay, first of all, ratios. It's kind of like what we talked about yesterday. They can be used to show how two quantities are related. Okay? How two quantities are related. By the way, today's work, once we start doing the work, you're going to recognize it because y'all have already done it this year. Here we go. Equivalent ratios. They describe the same relationship in higher terms or lower terms. Blah, 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 you're reducing fractions. That's basically what this is. You're reducing things. You can go up or you can go down. We've done this before. Equivalent means the same. So I'm going to do one more little quote definition, and then we're going to get started. Okay? Some of you really worked hard on reducing fractions, and y'all finally got it. So I think today's work is going to be not so bad for all of you people. All right, proportion. I think we've talked about this too. Proportion. All right, a proportion. It's an equation showing equivalent ratios. It looks like this. Here's a fraction with an equal sign and a fraction. There you go, proportion. And you remember when we had those? Remember what we did? Cross multiplication. You remember that? See, we've done all this stuff before. That's why I'm saying this is going to be so easy. All right, let's just jump in and start doing some stuff. All right, examples. Let's say it says, write an equivalent ratio in higher terms. An equivalent ratio in higher terms. Okay, this is the first part of your book, but I'm getting my examples from something else. Okay, so let's say it's 2/5. Now remember, the reason they're talking about this again is in the past we talked about this as being 2/5, but we're doing ratios. So we don't say 2/5 anymore, we're saying 2 to 5. But we're still treating it as a fraction as we need to, we can reduce it. In this case, we can't reduce it, but the direction said to do higher terms, and they need to be equivalent. So, let's say, and you're going to get this, I do 2 times 2. What do you get? 4. But what we do to the top, we have to do to the bottom. Remember that? So 5 times 2 is 10. There's your answer. That's it. So remember, in reducing fractions, they would give us something like this, and we would divide by 2, and we would get this. But since we're doing ratios, okay, and proportions and stuff like that, we're just finding equivalent fractions. These two are the same thing. See that equal sign? That means they're the same. Okay? Let's do 6/4. What would be an equivalent? You could do times 2, or you could even do times 3. Let's do 2 times 2 on both. Top and bottom. 12/8. 12 to 8. Not 12/8, but 12 to 8. There's your answer. We could also do times 3. 6 times 3 is 18. 4 times 3 is 12. You could do that too. You could do times 4. 6 times 4 is 24. 4 times 4 is 16. So you could do this one or this one or this one. These are all equivalent fractions to 6/4. Okay? But, you know, we can always just stick with the easy 2 part, but still, that's how you do this. You just find, you know, what you do to the top, you do the same to the bottom, and you get an equivalent fraction. What about if I had, speaking of ratios, 3 to 9? Again, we're doing ratios. They look like fractions, and we're kind of treating them as that, but they're not. This is 2 to 5, 4 to 10, 6 to 4, 12 to 8, 6 to 4, 18 to 12, etc. This is 3 to 9, but we need to get an equivalent ratio. It's in higher terms. You're going to do the same thing. Times 2 times 2. What you do to one side, you do to the other. 3 times 2 is 6. Colon, 9 times 2 is 18. Or you could do times 3. What you do to one side, you must do the other. So 3 times 3 is 9. 9 times 3 is 27. Either one. Okay, let's do some more. Now remember, we're going higher. This is if they want an equivalent ratio in higher terms. Notice we're going higher. See how we're going higher? The numbers are getting bigger. We're still in higher, we're going higher terms. How about 4 to 6? Well, we can do times 2. 4 times 2 is 8. 6 times 2 is 12. We could even do, or we could do 5. What you do to one, you must do to the other. 4 times 5, 20. 6 times 5, 30. We could do, again, we could have another fraction. And let's see. How about if we do times 10? What we do to the top number, we do to the bottom. And remember, we're looking for a higher term. So 2 times 10 is 20, and 7 times 10 is 70. That's definitely higher, and they're equivalent. Okay? What if the directions say, this time, write equivalent ratio in lower terms? Equivalent ratio, not a fraction, but it may look like a fraction, in lower terms. This is where that reducing comes in. So we're getting lower, reducing. What number can be divided into both of those, top and bottom? 2. 8 divided by 2 is 4. 6 divided by 2 is 3. See, y'all have had this before. How about 8 over 12? What is the largest number, or any number, that can go into the top and bottom? We could say 4. 8 divided by 4 is 2. 12 divided by 4 is 3. Now, those are equivalent. What if I chose 2? Because 2 can go into both. 8 divided by 2 is 4. 12 divided by 2 is 6. Guys, that's an equivalent fraction, or equivalent ratio. That's also equal to this. And it's in lower terms. So as long as it's lower and it's equivalent, you're good to go. Let's do some more. How about 3 to 9? Well, we can divide both numbers by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. How about 4 to 10? We can divide by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. Again, lower terms that are equal. Where each time we're going lower. It's like reducing. This one over here, we needed equivalent ratio. I should have written that. That was in higher terms. So we multiplied. Notice we multiplied each time to make it go larger. This one we're getting in lower terms for, so we're dividing it. How about this one? What number can go in top and bottom equally to make it smaller? 5. 10 divided by 5 is 2, and 15 divided by 5 is 3. About 18 to 9. We could do by 3. 18 divided by 3 is 6. 9 divided by 3 is 3. Guys, we're not looking to reduce all the way to lower terms, but that's kind of what you're doing. But and this isn't in lowest terms, that's okay, because we're doing ratios, and all they asked for was a lower term, not the lowest term. If you feel more comfortable putting it in lowest terms, we would divide both numbers by 9. 18 divided by 9 is 2, and 9 divided by 9 is 1. Okay? Now, if that's confusing, go back and rewind and watch that again, okay? All right, let's do, what if they said complete the proportion. Okay, so let's say they give you 3 over 4 and 8. And this is our mystery number. Okay, we don't know what that is. How many times 4 go into 8? So 4 times 2 gives us 8. Well then 2, what we do to the bottom, we have to do the top. 3 times 2 is 6. See how that works? 4 times what gives you 8? 4 times 2 gives you 8. So then we got to multiply the top number by 2 as well. There's our proportion. There it is. See? 2 fractions with an equal sign. Let's do another. I'll do it over here. I got 3 more of them sitting here free. 5 over 3 equals 25 over mystery number. All right, 5 times what gives you 25? 5 times 5. So then if we do 5 times 5 gives us 25, then we have to do it down here. So 3 times 5 is 15. So 15 is our missing number. So it'd be 25 to 15. Or you can just write the number in. I don't care. So another. 4 to 10. And they give you 100. Okay. Let's see, I'm going to call on someone. Raimi. How many times does 10 go into 100? Or you could say 10 times what gives you 100? 10 times 10. Therefore, Madeline, what do we have to do at the top? Times 10. So 4 times 10 is 40. Let's see. One more. All right, Ted. 1 times what gives me 3? Very good. 1 times 3 gives me 3. So Etta, 7 times what? 3. So 1, if we are doing multiplication of 3 on top, we do it on the bottom too. 1 times 3 is 3. 7 times 3 is, that's right, 21. Okay, I think you guys have a good understanding. Y'all done this stuff before. If this is confusing because maybe I went too fast or something, go back, rewind, and watch it again. This was a very short one. It was less than 20 minutes. So for homework, you're only doing page 367, numbers 1 through 14 all. All right, and that is due, what is today? Okay, so this is Wednesday, it's due Thursday. Okay, and let's see, you have a quiz on Monday, and you have IXL that's due Tuesday. Okay? All right, if you have any questions, let me know. Talk to y'all later. Bye-bye.